So today we're going over ratio tests. So now, do you remember these? What's 5 factorial? 5 times 4 times 3 times 2 times 1. So that is 5 factorial. So remember factorials, right? Yeah.
When have we ever seen?
When have you ever seen this? It's over. Yeah, there you go.
Somewhere you start studying how I remember doing it in geometry.
Did you do CPM geometry? If you did, I'm sorry.
I don't.
I don't. I love engineering.
Who taught your geometry class?
On head right now.
Well, 5 and
So it might have been CPM geometry. Now, anyway, how can I simplify n plus 1 factorial? All right, what is happening every time we progress? It goes down by 1, right? So n plus 1 factorial is n plus 1 times n plus 1. What is n plus 1 minus 1? N factorial over n factorial, which gives you what?
Oh, n
plus 1. You're going to want to remember that. Because if you go down by 1, you'd have n plus 1 factorial, or n plus 1 times n plus 1 minus 1, which is just n, times n minus 1 times n minus 2 times n. So it would just be n factorial after that point.
Oh.
So you know that if you have n plus 1 factorial, you can rewrite that as n plus 1 times n factorial. And that will be helpful. How can I simplify the second one over here? What can I rewrite this as? And we've done this before with e. All right. 3n times 3 to the 1 over 3n. Just gives you 3. Anyway.
Okay, wait, what? Literally yesterday we were saying we didn't want to.
You couldn't because you're adding. If it was x squared plus 2 over x squared, you can't do that. But if you're multiplying, you could. All right. So, ratio test for convergence. If the sum of n equals 1 to infinity of an has positive terms, so we are not going to be dealing with negative values here, and the limit of a n plus 1 over a of n is less than 1, then the series converges. If it is greater than 1, then it diverges. If it is equal to 1, then we use another test. All right. Now, by the way, do you remember what these are? All of these are, when you're doing the limit as n goes to infinity of a function over another function, what are you looking for? The horizontal asymptote. Well, the last one, I mean, for all of them, basically, yes. But yeah, you're looking for the horizontal asymptote. So if the horizontal asymptote of an plus 1 over a of n is less than 1, then it converges. If it's greater than 1, it diverges. If it equals 1, then we can just don't know. Different test. So let's look at some functions we already know. We already know that this is a harmonic function, which we know this also what? Diverges. So we already know this diverges. So we know if we do the ratio test, this will diverge. Okay? And we can show this. Actually, do we know that? Well, let's see what happens. Let's take, what is a of n? That is 1 over n. What is a of n plus 1? Yeah. And that is subscript, so yeah, it is just, we're adding 1. We basically replace, every time we see n, replace it with n plus 1. So that's 1 over n plus 1. So we take the limit as n goes to infinity of a of n plus 1 over a of n. Again, this is subscript, just making sure we know that. Is equal to, now again, do I want to write a complex fraction? So what's an easier way to write this? Yeah, multiply by the reciprocal. So it is the numerator, which is a of n plus 1. So 1 over n plus 1 times the reciprocal, n over 1. Now this is going to give you n over n plus 1. And I'm forgetting something. What am I forgetting? I'm forgetting to write the limit as n goes to infinity of n plus 1 over, or n over n plus 1. What happens here? What does this give you? 1, which means this is inconclusive. Inconclusive usually has an in for the beginning. Inclusive. Yeah, we don't know. So we do know it does diverge, but the ratio test would show inconclusive. All right, what about a p-series? What we know this is a p-series, and again, because we memorized this, because we're such good students, if p is equal to 2, which is greater than 1, then what do we know? It converges. So for those who didn't come in early enough for me to tell you this, you will be allowed that cheat sheet on your test, just because we just don't have time. So let's take the limit as n goes to infinity of a of n plus 1 over a of n, which gives me the limit as n goes to infinity of 1 over n plus 1 squared times n squared over 1. Now this also gives you the limit as n goes to infinity of n squared over n plus 1 squared, which gives you 1. So this is also inconclusive. So far, not super helpful, right? But again, it's nice that we already know that these diverge or converge. What is nice about this is the fact you don't have to remember a lot of stuff. You don't have to do that this function is greater than this function. If this function converges, then the other converges. And if it's less than this function and this diverges, then that diverges. You don't have to know all that stuff. You just have to say, well, if I take the limit of n plus a of n plus 1 over a of n, and I get less than 1, it converges, greater than 1, it diverges. Anything else, I just use a different test. It's a very easy test to remember how to do. Okay? So, let's look at this fun thing. By the way, let's just write this note. The ratio test is always. Now, we don't use definitive terms like always unless it is an absolute truth. All right, is always inconclusive p-series. So don't use it. So don't use it for p-series. If you know you have a p-series function, then we should know how to solve those anyway at this point. So don't use it for p-series. Now, specifically, this one isn't a p-series because we have more than just. Well, this isn't p-series anyway because it's not n to the exponent. Well, we do have n squared, but we have more than just that. All right. So let's do. Hey, you're late. Where the rest of the notes at? Kayla, where the rest of the notes go? Oh, right in front of me.
I was like, I.
You just keep hiding things right in front of me. All right. Let's hear it. All right. So we do the ratio test. We need to know a. We know what a of n is. What is a of n plus 1? So we took everything, every n, we wrote n plus 1. We would have n plus 1 squared times 3 to the n plus 2, right? Over 5 to the n plus 1. So we're going to take the limit as n goes to infinity of this function, n plus 1 squared times 3 to the n plus 2 over 5 to the n plus 1 times a of n, right? So again, the reciprocal of this, 5 to the power of n squared times 3 to the n plus 1. So any questions on that setup?
Wait, you said you.
So Katie, just to make sure what we're doing is we're taking the limit as n goes to infinity of a of n plus 1 over a of n. And since they're fractions, we just took a of n plus 1 times the reciprocal.
Yeah.
Okay. So that pretty much catches you up. Except for the final result. You know, if the limit is less than 1, it converges. If it's greater than 1, it diverges.
Oh, that's all I'm
That's, yeah, it's up top. If it's less than 1, it converges. Greater than 1, diverges. And if it equals 1, we just use another test. It's inconclusive. Now, we also wrote down some things at the very top on how we can simplify these types of functions. How can I rewrite that right? Well, how can I rewrite these right here?
So n plus 1 squared times 3 over 5 to the n. Actually, that's really bad.
So this is my numerator. It's all multiplication. So I have n plus 1 squared. I do have that. I have 3 to the n and 3 squared because 3n plus 2 can be written as 3n times 3 squared. And then 5n. That's my numerator. My denominator is 5n times 5 to the 1 times n squared times 3n times 3 to the 1.
That cancels out.
Yes. So a lot of stuff cancels out. So 3n, 3n.
Oh.
Right, so 3n and 3n cancel, right? Yeah, I'm not done. I'm just, you said wait, so I stopped.
Like that on the last 3 to the n.
We just had to show that yesterday that it was a decreasing function. So nothing really canceled out. We just showed that the numerator was less than the denominator. We can't cancel the n squared, but I can cancel out one of the threes, right? So this 3 squared becomes 3 to 1. That 3 is gone. So what I have up top right now.
Whoa. Where did that 3 come from?
This 3 right here.
Because the same idea with the
3n plus 1 and 3n plus 2. 3n plus 2 becomes 3n times 3 squared. 3n plus 1 becomes 3n times 3. All right. And then the 3 squared and the 3 to the 1 reduced to just 3 to the 1 up top. So up top I have, yeah, give me a second. Erase some of this mess. All right. So up top we have 3 to the n plus 1 squared. On the bottom we have 5 to the n squared. So what does that go to? 3/5. Which means this is less than 1, so this converges.
Yeah, this is the most pointless unit ever.
Wait, is this whole unit like is our test just gonna be like figuring out if stuff converges or not?
Yes.
Okay.
There are some questions that ask you to find the sum, but I'll show you what we need to do in those situations, or what it converges to if you have a geometric or other test. So,
I've got already know so basically with interactions.
Sure.
That's what I was doing on the Dulce math. I would just do diverges the first time, and then if it was wrong, then I would actually figure out.
that's pretty smart, actually.
Well,
Alright.
wait, so
Any question number 3? No question number 3? Okay, number 4. Here we know a of n,
Factorial.
factorial.
Times by every number added together.
Yes.
But why? Why would we do that?
What's the question?
You do that with counting problems, and you do it in statistics as well.
Yeah, I'm good.
Yeah, because that gives you the total number of possible options. Yeah. Yeah, combinations and permutations.
Right.
All right, so a of n plus 1 is what? 4 to the n plus 1 over n plus 1 factorial. Now, up top, we already showed you what happens to n plus 1 factorial, so
Over.
yeah, just you'll see what happens. So we take the limit as n goes to infinity of 4 to the n plus 1 over n plus 1 factorial times the reciprocal n factorial over 4 to the n. Right? Now, we wrote up top that n plus 1 factorial can be written as n plus 1 times n factorial.
Where do we write this?
At the very top. N plus 1 factorial equals n plus 1 times n factorial. Because again, if you remember, you multiply by every number less. So what's one number less than n plus 1? And then you keep going, so that would just be n factorial after that. So we can write this as the limit as n goes to infinity of 4 to the power of n times 4 times n factorial over n plus 1 times n factorial times n factorial times 4n. So here, what's going to cancel out? N factorial and 4n. So we're left with the limit as n goes to infinity of 4 over n plus 1, which is
4.
0.
Why?
Because you only have n in your denominator. So it goes to 0. Again, your horizontal asymptote, remember, if your denominator has the highest degree, it automatically is 0. And this is why, if your denominator has the highest degree, it automatically goes to 0, because as your denominator goes to infinity, what happens to your fraction? So less than 1, so this means this converges.
Separate out the like
Yes, you can do that, yeah. So again, ratio test not too bad so far. So let's look at number 5. All right. Yeah, let's look at number 5. What is a of n plus 1? Again, this is subscript plus 1. So that is 2 to the n plus 1 factorial over n plus 1 to the 5th power. Yeah, they gave you last space for this one. Now, let's make a little note over here. How can I simplify 2 to the n plus 1 factorial? So first we distribute the 2. All right. So if I start with this, I'm going to have 2 to the n plus 2. What's my next number? 2 to the n plus 1. And then that would just be 2n, right? And then every number below 2n can be written as 2n what? Factorial.
Oh, right.
So we have the limit as n goes to infinity. All right, we've already simplified this, so I'm going to go ahead and write it as a simplified version.
Cross out exclamation marks from the top and the bottom.
If they both have the same factorial only. You can't just cross out exclamation marks. It has to be attached to a value. Now, the reason why we wrote it like this is because now I have 2n factorial on the top and the bottom. All right, of n to the 5th over 2n factorial. So in this case, I can cross out 2n factorial. And that's it. That's all I can cross out. So I have the limit as n goes to infinity. You don't have to multiply this through. 2n plus 2 times 2n plus 1 times n to the 5th over n plus 1 to the 5th. What is your degree in your numerator?
Oh. 7 over 5.
Yeah, 7, and your degree is 5, right? Now, what happens when your degree of your numerator is greater? Goes to infinity, which is greater than 1, so this diverges.
Why did you find some on the other one but not that?
What do you mean?
This way.
Can I use the bathroom and get my computer from the second hour?
Okay. Alright. So, a lot of questions on here. There's not a delta math on here now. Let's see here.
And factorial is and factorial. When you tell me that. And factorial becomes 1 plus 1 factorial.
Oh, the rest of this is homework?
Yeah. Well, we're going to go through some of these together. All right. Do you want to try the first two and see how you do? Okay. So go ahead and try the first two. So back to so number 1. What is a of n? N plus 1, sorry. That is n plus 2 times 3 to the n plus 1 over n plus 1 factorial. So we take the limit as n goes to infinity of n plus 2 times, I'm going to go ahead and simplify as 3n times 3 to the 1 over n plus 1 times n factorial times the reciprocal n factorial, okay, over n plus 1 times 3n. So it's going to cancel 3n and n factorial. So right now I have the limit as n goes to infinity of n plus or 3 times n plus 2 over n plus 1 squared. And since my denominator has the highest degree, this is automatically 0, which is less than 1, so this converges.
Less than that. Yes, and less.
Actually, converted.
All right. So the second one, a of n plus 1 is equal to n plus 1 factorial over 5 to the n plus 1. So the limit as n goes to infinity over, and I'm going to go ahead and simplify this to be n plus 1 times n factorial over 5n times 5 to the 1 times n, a reciprocal, so 5n. Try that again. So the reciprocal, 5n over n factorial. Here we have n factorial cancels and 5n cancels, so you're just left with the limit as n goes to infinity of n plus 1 over 5. Now, since your numerator has a greater degree, what does this go to? Infinity, which is greater than 0, so this diverges. Those are nice. Again, I like the ratio test. I think it's not that bad.
You can just do that with everything.
No, because if you get equals 1, then you got to do something else.
No, you're.
But yeah, I mean, if you have it, again, honestly, anytime you see something factorial, you probably want to use the ratio test.
Alright.
All right. So here, what are the values of x is greater than 0 for this series? So we're going to do a of n plus 1. What does that give you? N plus 1 times 6 to the n plus 1 over x to the n plus 1, which we can simplify to be n plus 1 times 6 to the n times 6 over x to the n times x, right? So we take the limit as n goes to infinity of n plus 1 times 6n times 6 over xn times x times, x to the reciprocal x to the n over n times 6n. So 6n cancels, x to the n cancels. We're left with the limit as n goes to infinity of 6 times n plus 1 over x times n. All right, which we could write this as the limit as n goes to infinity of 6 over x times n plus 1 over n. Right? Now, we know that this is going to go to 1. All right? But we want this to be what? In order for this to be convergent, we want this whole thing to be what? Less than 1, right? So in order for this to be less than 1, that means that 6 over x must be less than 1. X has to be greater than 6.
So is it absolute value? Because what if it was negative less than?
Wait a minute. In the directions it says for what value is x greater than 0. Okay, but yeah, I mean, good question. In this case, x is still greater than 6, so it wouldn't make much of a difference.
If it didn't say.
No, because I think if you look at the very beginning of the notes,
Has positive sign.
there you go. All right, what are all the positive values for p in which the series will converge? What was that? Yeah, P has to be what? So we do the same thing. A of n plus 1 is equal to what? N plus 1 to the p value over 7 to the n plus 1, which we can say n plus 1 to the p value over 7n times 7, right? So we take the limit. P, yeah. N goes to infinity of n plus 1 to the p value. Not writing small. 7n times 7 times 7n over n to the p value. So in this case, that cancels. I get n plus 1 to the p value over 7n to the p value. Now, that means that no matter what p is, this ratio is going to go to what? 1 over 7. So this will go to 1 over 7, which means this converges. So p just has to be what?
More than one. No.
Anything. Any positive term. Yeah. P just can't be negative. That's all. No matter what, that's going to go to 1/7. Because again, when you plug in a value, are going to get the same exponent on the top and bottom. And if your numerator and denominator have the same degree, then it converges to the ratio of leading coefficients, which in this case is 1 and 7. So yeah, as long as p isn't negative, you're good. Which of the following series converge? It's just a number. It's a constant. It's an irrational constant, but it's a constant. So if you want, that's fine.
Oh, thanks.
So if you want to do a to the n plus 1 gives you pi to the negative 2n plus 2, right? Over n plus 1, which is pi to the negative 2n times pi squared, right? Over n plus 1.
Wait, shouldn't be negative ways.
Oh, you're right. It should be minus 2. Well, good catch. Minus. So that should be negative 2. So we take the limit. As n goes to infinity of pi to the negative 2n times pi to the negative 2 over n plus 1 times n over pi to the negative 2n. So that will cancel. So we get n, well, we take limit as n goes to infinity. I'm going to move pi to the bottom. So we have n over pi squared times n minus, or n plus 1, which just gives you 1 over pi squared, which is less than 1. So this converges.
Oh,
So yeah, because it did end up being negative, yeah, that's the only reason it converged. If it had been positive, it would not have converged.
A 1.
So we're going to do number 2, I guess. A of n plus 1 is equal to n plus 1 factorial, which we know that to be n plus 1 times n factorial. Now, that's how that is writing pretty small. Over n plus 1 to the 20th, n plus 1 to the 20th. So limit
20?
times n to the 20th over n factorial.
Why is the denominator n plus one to
So it's D.
Sorry, 20th.
It's D. Right?
So that will cancel this out,
Yeah.
but I end up with a numerator that has a degree of 21 and a denominator degree of 20, which means this is going to go to what?
1.
Infinity, so it diverges.
1 degree over.
Yeah, degree of 21 of degree of 20, yeah, diverges. And the other one's going to be
Converge.
This will converge. We take the a of n plus 1 is 7 to the n plus 1 over n plus 1 factorial, which is 7n times 7 n plus 1 times n factorial. We have like 3 minutes left. 7n times 7 over n plus 1 times reciprocal. Don't forget it's reciprocal. N factorial over 7n. So here cancels. I end up with 7 over n plus 1.
That's
starts at 6 real quick? Maybe number 7.
Which gives you 0, so this converges. D. Ratio test applies to this series. Which of the following inequality results implying that the series converges? Oh, so they want you to know what was the simplify down to. Okay, number 7. If a of n is greater than 0, which means positive for all n, and the limit equals 6, which of the following series converge? Okay. Well, we know it's not A. How do we know it's not A? Because he just told us the limit of a of n plus 1 over a of n is equal to what? 6. So that would mean that that is greater than 1, so that diverges. So we do know it is not A, because this already says the limit as n goes to infinity of a of n plus 1 over a of n is equal to 6. So that's greater than 1, so this diverges. So not A. All right. For this, okay, just do that. Just jump around on me. Here we get a of n plus 1 over n plus 1 to the 7th times n to the 7th over a of n. That gives you n to the 7th over n plus 1 to the 7th. So this will be 1. That will give you worse. That'll give you 1, but it's also times a of n plus 1 over a of n, which this we know to be 6. What's 1 times 6? So this is 6 is greater than 1, diverges. All right. This one we get a of n plus 1 over 7 n plus 1, which is a of n plus 1 over 7n times 7. And we're going to multiply that by 7n over, or 7 to the power of n for a of n, so that's gone. So we get a of n plus 1 over 7 times a of n, which is 1/7 times a of n plus 1 over a of n, which is 6 over 7. So that is less than 1, so this converges.
Would E not also be 100?
No, because you end up getting 36, because you end up squaring
Oh,
36 over 7. All right, that's fun. Not much left to do on homework, really. This looks like a really fun question.
I think I understand how something. Maybe.
Oh, I forgot to give you guys the review.
Ah.
I have the test review.
I have that.
I would do it either. I would remember this again. I'll worry right now.
There it is.
On the homework, I'm not a good student. I'll do it next week.
I think it'll get done eventually. I mean, it'll get done.
What?
I'll do it next. I'll do these 4 games and I'm not gonna do
You know, it's such a critical good paper.
I'll do it next week, guys. I'm not gonna do it today. It's pretty good.
Thank you, though. Much appreciated.
What?
Overall, good service.
And we still have one more lesson anyway.